there is one big misconception among many of you about how force and Newton's second law of motion work. So here I have an object, and let's say there are two forces acting on this object, which is a power bank. Let's say I have a force acting in this direction called F1, and I have another force acting on this object in, let's say, this direction, and let's name that force F2. Now I have a force acting in this direction called F1 and a force acting in this direction called F2. Now let us apply Newton's second law of motion to this scenario here. First of all, what you need to, what does Newton's second law state? Well, the mathematical form of Newton's second law is simply F equals ma, or the force on an object equals its mass times the acceleration that we get on the object due to the application of that force. Now the big thing to note here is that the F here stands for the net force on the object. It is not the individual force that matters, it is the net force that matters on the object. So it is only the net force that causes an acceleration. Remember, if we state the first law of Newton, it says that only a net external unbalanced force. So net is an important word here. So this is the net force here. So how do you find the net force here? Well, let's say F1 and F2 are two forces which are equal in magnitude. So that would look something like this. I am pulling this power bank in both directions with equal force, and the power bank will not move in either direction, right? So in such a case, you have zero acceleration, which means we have zero force, zero net force actually, because F1 and F2 cancel exactly. If in case, let's say we have the F1 force is higher, then obviously this force would win the tug of war and the object would start moving in this direction, right? It would accelerate in this direction. Or on the other hand, if F2 is greater than F1, then this force wins the tug of war and the object starts accelerating in this direction. So that is the basic idea behind net force. And how do I find the net force in this particular case? Well, I can subtract the smaller force from the larger force. Well, if the forces are equal, then F1 minus F2 or F2 minus F1 both are the same thing. But in case, let's say F1 is larger, then what I can do is, let's say F1 is 10 newtons and F2 is 8 newtons. So F1 is larger. What I can do is, to find the net force F net, I can simply subtract F2 from F1, and when I subtract F2 from F1, I get the net force, and the net force in this particular case would be F net equals 10 newtons minus 8 newtons, which gives me 2 newtons. So the net force on this object in this particular case is 2 newtons. So if let's say the mass of this particular power bank is, let's say 2 kgs, I know it won't be that heavy, but let's assume it's 2 kgs. Now if I apply the Newton's second law to this, I get, well, I'll just apply it here. The force here is 2 newtons. Remember, it's a net force, so I'll take 2 newtons. I won't take 10 newtons. I won't even take 8 newtons. I'll take 2 newtons because that is the net force on the object, and that equals 2 kgs into its acceleration. And now I can shift this 2 kg to this side, and when I do that, I get 2 newtons per 2 kg upon divided by 2 kg equals A, and 2 divided by 2 is simply 1. So the acceleration I get is 1 meters per second sorry, this wasn't visible, but I hope you get the idea, right? So when I shift this 2 kg here, I get 2 newtons divided by 2 kg, and 2 divided by 2 is 1, so I get 1 meters per second of acceleration. So the basic idea here was to show you that it's a net force that matters, and the individual forces do not matter. Even if this was, let's say, instead of 10 newtons I had 14 newtons, and here instead of 8 newtons I had 12 newtons, the net effect would be the same, because 14 minus 12 is 2 newtons, and so the net force on the object would be again 2 newtons, and the net effect, or the effect on this object due to these two forces, would be the exact same as was in the previous case, because the net force is 2 newtons, which is the same. So it is the net force that matters, not the individual forces. So now keep in mind, whenever you're doing any question and you're applying the Newton's second law, it is only the net force that matters, not the individual forces. That's it for this video.